All right, this is an application problem from section 4.2, and it deals with a revenue. You'll have a few of these in your homework, and probably assigned almost nightly throughout this chapter, just because it is a challenging problem. I think once you grasp it, it won't be so challenging. I can guarantee you'll see a problem like this on your exam, so just really getting comfortable with how to attack a problem like this. So what I'd like to do is just read the problem and kind of set it up and talk about where things come from, and then we'll actually answer the question. So it says a video store sells about 150 DVDs every week at a price of $20 each. The owner estimates that for every $1 decrease in price, about 25 more DVDs will be sold. How can the owner maximize weekly revenue? All right, now you're going to be asked to define variables. This is not going to be something that I'll do for you, of course, on an exam, but I did define it here. So if you think about it without even looking at what I've defined, if you know that you sell 150 DVDs at $20 a piece, you would take the number of DVDs times how much you charge per DVD, so 150 times 20 is $3,000. That would be your profit or your revenue, if you're not familiar with what revenue means. However, it's known that if you decrease this by $1, so let's say you charge $19, then you're going to sell, 25 more DVDs. So that means if you charge $19, you're going to sell 175 DVDs, and etc. If you decrease it to $1 decreases, that would mean you're charging $18, and then you're going to sell 200 DVDs. I think you get the idea. So we want to know how many of these $1 decreases will maximize our revenue. So I don't know what that is, so that's going to be my variable. X is the number of price reductions, and specifically the number of $1 price reductions, right? And then R of X is going to be my weekly revenue based on, of course, my price reductions. So I've set it up here in words first, and note I put revenue in dollars equals the price that you charge, so dollars per DVD, times the sales, so how many DVDs you sell. And I want you to think about this. If I fill in the equation here, I know that my revenue is 150, or I'm sorry, I have price here. Let me make sure I follow my words, right? So my price is $20, and my sales are going to be 150. However, for every $1 decrease, so that means if I take my $20 and minus $1 times X, because I don't know how many times I'm going to do that, that is going to increase my sales by 25, and times X also, because however many decreases I do here is going to be how many increases happen here. And of course I'm multiplying these together, so I better put parentheses around it now that I have a quantity situation. And that's it. So now I want you to look at this. Pause the video, think about what form is this in? Well, it's obviously an x-intercept form. So to me, whatever form your problem is in, I would utilize that. And I embrace x-intercept form, so I have no problems with this. So I know if I set each of these equal to 0 and solve, I will get my x-intercepts. So this one's easy. I'm going to have an x-intercept at 20. And if I divide by negative 25, that's going to be negative 6. So thinking about this, I'm going to scooch this up to give myself a little room. And I'm not going to draw this to scale, but I know it's going to intercept at negative 20, or sorry, positive 20 and negative 6. And I also know that it's opening down, and I know that because a negative x times a positive 25x would be a negative 25x squared. So my a value is going to end up opening down. And again, I'm not going to draw this to scale, but it would, as I totally missed those, look something like this. So where is my vertex going to be? Well, my x-coordinate is definitely halfway in between these two x-intercepts. And if I don't know what's halfway in between, I add them together and cut it in half, but that's going to be 7. And then I put 7 back into these for these x's of the original function. So if I find my revenue, which is my y, I'm going to put x in there. And this would be a calculator problem for obvious reasons, but that's going to be 4,225. Okay, so that vertex right there is 7, and then 4,225. Now again, to me, that was relatively easy. Okay, now I'm going to attack it one other way, but I want you to understand, first of all, what in the world did we just find? So what is x again? Okay, and let me just scoot this up a little so we can see it. So what is x? Well, x is the number of price reductions. So I'm going to have 7 price reductions, specifically $1 price reductions. So if I was originally charging $20, now I'm going to do 7 $1 price decreases, which means I'm going to be charging $13. So I'm going to charge $13 because 20 minus 7 is 13. And that's going to give me, what is y or what is r, right? That's going to give me a revenue, a maximum revenue of $4,225. And I really just answered the question, and in case you forgot the question, it says, how can the owner maximize weekly revenue? Well, if they charge $13, they're going to maximize their revenue at $4,225. Okay, now I do want to work through this one other way and reference your calculator, because on your exam, you're going to be able to solve this however you would like. So if this makes sense, great. If not, hold on to your hats. Okay, you can also, I have the equation up here, FOIL this out. So if you prefer, you don't enjoy x-intercept form, shame on you, you can FOIL it out. So if I FOIL this, 20 times 150 is 3,000. 20 times 25x minus 150x, I'm going to do that all in one step if that's okay. So that's going to be plus 350x, and then a negative x times 25x is minus 25x squared. And if you want to put that all in standard form, no problem. So you're thinking to yourself, okay, A is negative. I know I'm going to have something that's opening down. I'm looking to maximize profit. So I'm looking for that vertex, right? Maximize profit. So because it's now in standard form, I could do the opposite of B divided by 2A to find the x coordinate of that vertex, right? So the opposite of B divided by 2 times A, and that's 7. Okay, so my vertex is 7 something, and then of course I can put in 7 for all of the x's, and I would dump that into my calculator. Of course, I've done this, just did this problem, so I already know that that's going to be $4,225. All right, so that is your vertex. And again, I will just verbalize this answer, but I know that I'm going to have 7 $1 price decreases, so I'm going to charge $13 to have a maximum revenue of $4,225. Okay, now again, I don't know if you prefer, if you think this is easier, it's a little more work because you have to FOIL this, and then you have to do a little more work to find the vertex. Although in intercept form, you have to do a little work to find the vertex also. So again, it's really up to you. Okay, your last option, and my personal favorite probably, is just dump this on my calculator. Okay, so I want you to do this, and I'm not going to show this on this video, but if you type this into your y equals, this is y, remember, you do not have to FOIL this out. In fact, I wouldn't, because what if you make a mistake FOILing? Then you're going to have, everything's going to be wrong. So just type this in as is with the parentheses. Okay, into your y equals, clear out old stuff, make sure plots are turned off, all that good stuff. Watch my calculator videos, right? And then when you graph this, remember I always recommend just doing a standard window. You're not going to see this, okay? Because it's way up there at 4,225. Obviously not fit in a standard window. So then you got to think about this. X is the number of $1 decreases. Well, if you're charging $20 originally, X is not going to be a large number because you're not going to surpass 20 because then you're going to be charging negative dollars, right? So you know that your X window is probably fine from -10 to +10. However, Y is revenue, and you know that that's probably going to be more than $10 because you're charging $20 per DVD. So if you think about it, 20 times 150 is $3,000, and you know that you're looking to maximize profit, so it's going to be more than that, but probably not so extreme because you're not dealing with super huge amounts here. So you would adjust your Y max until you see this, and maybe it takes you 2-3 times to adjust it until you see this, and that's okay. Okay, now once you adjust it, and I'll jot this down for your refresher. Once you see what you want to see, you're looking for this. So you go to calculate on your calculator, and you're looking for maximum. Okay, it's going to ask you for left bound and right bound, or lower bound, upper bound, depending on your calculator model. And remember, you want to go a little bit to the left and a little bit to the right of it and press enter, and then it's going to hone in on that vertex for you. So to me, that's ideal because really all I need to do is the hard part, and that's coming up with this equation right here. But then I can put it on my calculator and just find that answer. So I laid out 3 options here. I know it was lengthy, but like I said, these problems are a little bit challenging. So take a second, decide which one of these 3 methods you think was easiest, and go with it.